My name is Nazeer from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada, and for those international viewers, welcome to you also. What we are looking at is vertical projectile motion. The following problem, the following function is gives the position of an object thrown upwards from the top of a building. Displacement is in meters and time is in seconds. This is the function that we are given, and it's asking 5 questions here. From what height is the object thrown from? So it's asking for the height of the building right there. Right? So that's a displacement. What is the initial velocity? At the top of the building, what was the velocity given to the object at that point? When does the object start to come down? When is going to be a time, right? So when is the object start to come down? From the highest point, when does it come down? How high does the object go? Okay, so that's a displacement function also. How long is the object in flight? So that's a time. And what is the impact velocity? So that's a 2-part question. It's asking for time and impact velocity. Let's go and look at this. This is the initial problem that was given. When we look at the calculus part of this particular problem, when we have displacement, which is this function right here, and we take the first derivative of displacement, it gives us the function of velocity, right? And when we take the first derivative of velocity, it gives us acceleration, right? Acceleration due to gravity. If we were doing integration, we could go backwards too, but we're not going to discuss that right now. Let's look at getting the equations for displacement, which is given right there, the equation for velocity, and the equation for acceleration. When we look at the displacement formula, it's given. It was given right in the problem statement. When we look at the velocity formula, well, how did we get that? We had to take the first derivative of displacement, and that's what this is saying here. Velocity is equal to the first derivative. The hyphen really expressed the first derivative. If it had 2 there, it would be the second derivative, the first derivative. Let's go and do the derivative of this particular term. To take the derivative, you multiply by the power and you reduce the power by 1. So I'm going to take 2 times minus 4.9, which will give you 9.8, and you reduce the power by 1, so this becomes a 1 power. Okay? When we look at the second term, we have an understood 1 here, so 1 times 9, and then you reduce the power by 1, it becomes 0. Anything raised to the 0 power is 1, so we end up just with 9, and right there. And the derivative of a constant is 0, so we don't have to worry about this guy. We know that velocity, meters per second, right? Velocity is going to be meters per second. If it was acceleration, it would be meters per second squared, but it isn't, it's velocity. Let's go and get the acceleration formula. It is the second derivative of displacement and the first derivative of velocity. So let's go and deal with that. Acceleration is equal to the first derivative of velocity, second derivative of displacement, and I'm going to go and use this particular equation, the velocity equation, and if I were to take the derivative, there's understood 1 times 9, and this becomes 1 again, so that will give minus 9.8 meters per second squared. This is a constant, it becomes 0. So we have all 3 of the formulas that we need. We have the displacement formula right here, we have the velocity, and we have the acceleration formula according to this particular diagram that we have here. Let's go and look at basically a diagram or a drawing of what we have. We have a building. We know right at the top of the building the velocity is 0, the initial velocity is 0, and the time will be 0. Right at the top, the vertex or the apex of this parabola, we're going to have 0 velocity, and the slope of the tangent line will be 0 too. I just threw that in there, but it's not going to be used in this problem. And then when we get right down here, time is 0 because it stops, and that would be an impact velocity. Now let's look at the velocity, how it works. The initial velocity is given, and that's a positive velocity. It goes up, 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 up until the vertex, and then it starts to come down. And this, when it starts to come down, it's a negative velocity, right? So we have positive velocity, 0 velocity, negative velocity, and then impact. Okay, so that's what we're dealing with. We have 0 time and 0 time. We have the impact velocity, we have the initial velocity, and we have 0 velocity right at the vertex. Okay, let's go and start solving our problems now. From what height is the object thrown from? From what height is the object? It's really asking for the height of the building. So that's a displacement. It certainly is not a velocity or an acceleration. It's a displacement, right? We know right at that point, time is 0. Time is 0. So if I were to take the displacement formula and substitute 0 for t, and I will get the height of that building. So that's what I've done here. And this becomes 0, that becomes 0, 6 meters. Okay, 6 meters is the height of the building. Let's go to the second problem. What is the initial velocity? What is the velocity given at this point? Right there. So we know at this point time is 0. We know we're going after velocity. I'm going to use the velocity formula with time being 0. And that's the velocity formula. I've substituted 0 for time. T here becomes 0 right there. So this term basically disappears, and we have 9 meters per second. Right? 9 meters per second. So fairly easy once you have these formulas solved already. Let's go for the third problem. When does the object start to come down? Well, we already discussed the initial velocity will be given right at the top of the building. It will take a parabolic shape, and that is the vertex, and it will start to come down from that point. So right at 0 velocity, because of acceleration of gravity, this slow down, slow down, slow down, 0 velocity, speed up, speed up, speed up because of acceleration of gravity. We have positive velocity, negative velocity. Okay, so when we look at this, when does the object start to come down? It's asking for a time. How long does it take to get to that point, the highest point, where 0 velocity is? Okay, I am going to use the velocity formula and equal velocity to 0. Right? Where is, really I'm asking, where is 0 velocity? This is the velocity formula, and I have taken this part equivalent to 0, and I'm asking, where is velocity 0? Well, velocity is 0 right there. Right? I'm going to solve this. I'm going to take that 9 over to the other side, become minus 9, divide by minus 9.8, and I will get my time. When you divide a minus by a minus, you're going to get a positive, so you have a positive time. So the time from here to there will be 0.9184 seconds. Right? Okay, so we've answered that question. When does the object start to come down? Well, it'll take that amount of time. Number 4, how high does the object go? So the highest point of the object is right there. How high? That's a displacement. That's a displacement. So if we know the time to that point there, which we just solved for here, and we plug that into the displacement formula, it'll give us the height. And let's go and do that. Again, we've taken the displacement formula. I'm going to go and plug the time in that I solved for there as a function, and I have a displacement of 10.13 meters. So this point here is 10.13 meters. Okay? And the last part of this, how long is the object in flight and what is the impact velocity? Two-part question. Time and impact velocity. So we're going to have to use our equation. How long is the object in flight? It's going to be in flight from here to there. Right? I'm going to use this displacement formula equal to 0 and solve for time. I'm going to have to factor it. Now, because of a partial number here, I'm going to have to use the quadratic formula. Right? This is A, B, and C. Right? So when we look at this, A, B, and C, and those correspond to this. I'm going to use the quadratic formula, plug those numbers in. I'm going to come up with two answers because a parabola usually have two answers, right? We know it's not going to be the negative time, it's going to be the positive time. We have 2.354 seconds, which is the correct answer. I have to choose that. Okay? Let's go and we know that from this point all the way down here, 2.354 seconds. I'm going to go and do the second part. What is the impact velocity? I'm going to use the velocity equation with this time and get the impact velocity. So it's again a function. I'm going to substitute 2.354 seconds right there and right there and come up with the impact velocity. And that's what I've done right in there. And you have minus 14.06 meters per second, which is your impact velocity. I hope that this gives you an indication of how to deal with vertical projectile motion type of problems. Have a great day, and hopefully I'll see you in another video. Thank you. Bye-bye.